Okay, so our topic for today, we are dealing with functions. We're not graphing them, so that might intrigue you. But instead, we're going to be performing operations with them. Okay. If we go back to that was the second example in the warm-up, when we evaluate f of x is equal to 3x plus 5 for when x is negative 2, what we did is we simply took that negative 2 and we plugged it in for x, and then we solved, correct? Okay, so we're going to be doing kind of the same idea today, but this idea of performing operations within these functions, now we're going to actually go ahead and do our addition and subtraction, multiplication and division between two different functions. So let's start with our addition. They're going to give you this notation in the book, and we read that as simply f plus g of x. And when you see that, what you are doing is you are taking the f of x function and adding it to the g of x function. It's that simple. And it is through this definition that is really, whether or not we get this right. Okay? As soon as you see this, you got to be able to say, oh, that's f of x plus g of x. If we look at the subtraction side of it, f minus g of x, well, that simply means we're going to take our f of x function minus the g of x function. We can do it with multiplication. F times g of x is simply taking the f of x function and times it by the g of x. And lastly, division. We have f of x divided by g of x. Okay, so let's go ahead and take a look at a couple of these, and I think once we go through an example or two, you'll start catching on to the idea. For example, 1, they give us the g of x to be x plus 4, the h of x is x minus 2, and we want to solve the following. Part A, we want to begin by taking h plus g of 2. Now, let's just set aside that 2 for the moment. Here's that h plus g. And when we see that, h plus g of 2, what that means is we need to add those two together. But notice it's no longer an x, it's 2, am I right? So let's just fill that in. Instead of h of x, it's h of 2 plus g of 2. Easy enough, right? It's function notation. We're plugging in a 2 for x. So instead of just evaluating for one function, we actually need to evaluate for a second one as well. So what we want to do at this point is we need to do a little bit of scratch work. We need to begin by finding h of 2. So let's go back to our h of x function. H of x was x minus 2, so 2 minus 2. So I find that h of 2 is going to be 0. Let's hang on to that for a moment. The other thing that we need to find is g of 2. So g of 2 is equal to x plus 4, so 2 plus 4. And I find that g of 2 is going to be equal to 6. So now that we did our scratch work off to the side, now we want to go ahead and do this. Do you have a question, Abby? Okay. Now we want to go ahead and fill these in. It's simple substitution. What do you suppose I'm going to plug in for h of 2? 0, because we found h of 2 to get us 0. And what did we find for g of 2? 6. Add the two together, and there's our final answer. Yeah?
Are these going to be used later on to make it like even more complicated stuff?
Save that for at the end of the lesson.
With functions like adding
Well, actually
and
not
then
today, but
multiplying functions. Like
Eventually,
multiple
possibly. Performing operations with them, it's usually just 2, so it's probably not going to get more difficult than this. When we get into composition functions, then we'll dive into that. Okay? H plus g of x. Now notice the difference between part A and part B. Part A, we were actually evaluating for a particular value. Here, they're just leaving it as x. So again, let's go back to the definition of this thing. What does this really mean? Well, h plus g of x simply means, if we go back to our definition before, that is h of x plus g of x. But are they asking us to solve for a particular value? No. Okay? So now we don't have to do any scratch work off to the side. But instead, what we're going to do is we're simply going to plug in the expression of whatever h of x was. So let's go back. H of x was x minus 2. So by substitution, we're going to replace with x minus 2. Same thing for g of x. Not solving for a value, so we're just going to substitute in whatever that expression was, x plus 4. We cannot simplify inside the parentheses, so essentially they go away. And notice this time, instead of solving for a particular value, because we're just leaving x be x, we're going to get an expression more than likely with the x in there. Okay with that idea? So really, when you perform these things, there's 2 things they can do to you. They can either give you the value or they cannot give you the value. And then you're just going to perform the operation between the 2 of them. Let's go to subtraction real quick. Looks like they're flipping the order on us. Now we want g minus h of negative 2. Per the definition, what does it mean? We got to be able to get started with it. Well, that means I'm going to take g of negative 2 minus h of negative 2. And if we go back and take a look, I'm going to write these down on the side over here. G of x, x plus 4, h of x is equal to x minus 2. That'll save us a little back and forth there. We're solving for a value, right? So now we actually got to do the scratch work off to the side. First thing, let's find g of negative 2. For the function, negative 2 plus 4. So there's that one. H of negative 2. X minus 2. Let's go ahead and plug it in there. And again, now it just becomes substitution. What did we find for g of negative 2? Well, I found 2. Minus, what did I find for h of negative 2? Well, I found that to be negative 4. Parentheses can be helpful, so as you can see, don't like the subtraction sign, so we'll change it to addition. In doing so, 6. G minus h of x. No particular value. So now it's just simply g of x minus h of x. Easy enough. We take the expression for each one. G of x is x plus 4 minus h of x, x minus 2. Now notice we have the subtraction sign there, right? Got to be leery of it because what does that tell us to do? Well, we have to distribute that negative. So the first one stays the same, but if we distribute this negative, that becomes a minus x and that becomes a positive 2. X minus x goes away, correct? 4 plus 2 is 6. So So this is a case where the x's happen to go away. Typically we get an expression with that x variable, but again, obviously we're in the mood for coming up with 6 today. Multiplication and division, it's the exact same thing. Okay, you're just doing a different operation in between. So I'm going to give you a head start. Notice we have new functions. H of x is x plus 3, g of x is x minus 6. And again, I will tell you, for those students that can write out this first step right here, more times than not, you know what to do from there. Oh, I just got to find g of negative 4, I got to find h of negative 4, and multiply the two numbers together. Final answers that we came up with? 10. H of negative 4 was negative 1 times g of negative 4, which we found to be negative 10. Last one, division. Again, I'll give you a head start. New functions, we have f of x, which is x plus 2, g of x, which is x plus 3. We're going to find f divided by g of 6. Don't be alarmed if you come up with that fraction or decimal. Questions? Let's do a few practice problems. Let's do A, D, and G.